Welcome to Unit 10. So we're doing triangles, and as you can see looking at this calendar, we have a lot of stuff to cover. We have 5 lessons, okay, and we are also going to do 2 reviews. Things may be moved around. I'm not sure exactly what I want to do. It depends on how you guys are feeling. We may put the first review earlier, before spring break or after. So just realize that this thing may change. All right. So we'll have spring break in the middle. We'll have a week afterwards, and then we will take the test. All right. So Unit 1, we're doing triangle basics. So a lot of this information you could probably come up fairly easily. Okay. So all triangles, or all angles of triangles, add up to give us what? Right, and we've talked about this before, so hopefully you remembered that a triangle gives you 180 degrees. All right, and so we're just going to answer some of these questions. Find the measures of each missing angle. All right, so if they give us 2 of the angles and we want to find the question mark, well, we know that 76 plus 58 plus whatever that is will give us 180 degrees always whenever we have triangles. All right, so you could just say 180 minus 76 minus 58, and that would leave us with, 46 degrees. All right, so these will probably be some of the easiest points on the test. The next one, we have this right angle tells us that it's 90 degrees. So we could do 180 minus 90 minus 60, and that will leave us with 30 degrees. All right, so not too bad. All right, and of course we have to make it a little more difficult. We want to find this measure, A, so that they give us the A here. We want to find what this angle is. All right, and they give us all the angles except we have X's in there. So you'll have to do a little manipulation to get what X is, but we know that 70 plus X plus 56, that's this triangle, or this angle, plus X plus 66 gives us this part of your angle, equals 180. So all you need to do is combine like terms and have X on one side, all the other numbers on the other side, and then solve for X. All right, so for example, we could subtract, so I'm going to change my color. We'll subtract 70 from both sides. Okay, we could also subtract 56 from both sides. Those would cancel. And then we can also subtract 66 from both sides. All right, and when you do those, you'll end up getting, when we still have these 2 X's, we can add those together. We get 2X. And if we put all of this together, put it in your calculator, you'll end up getting a negative 12. All right, and we're almost done. We just need to get X by itself, so we'll subtract 2 to both sides, and we'll end up getting X equals negative 6. Now you may say, oh, is it okay for X to be negative? Of course you can, okay? Because that's not like a degree or anything. If we had negative degrees, then maybe we'd worry, but when we have a negative 6, that's fine. This is what we're solving for. We'll just plug it in here. We'll say the measure of A, sorry, I'm doing that backwards, equals X, which is negative 6, plus 66. That gives us 60 degrees. Okay? All right, and B, or for 2B, it's basically the same thing. Okay, so just another example to try. If you can, pause and see if you can do it by yourself. All right, so we could say X plus 67 plus X plus 87 plus 40 equals 180. Okay, we could combine these numbers. So sometimes, I mean, you could combine all of these like terms, like these ones would be double, okay, so we get like 2x, and then you could do plus 194 when you combine this, this, and this. That gives us 194 equals 180, okay, and then you would want to subtract 194 from both sides. You end up getting 2x equals negative 14, or after you divide both sides by 2, would get x equals negative 7. All right, are we done? Nope, because it says this is for both a and b. We want to find that measure a. So we just plug that in, would do the measure of the angle A is equal to x, which is negative 7, plus 67, all right, and that gives us 60 as well, okay? All right, so that's kind of just like a quick review. I think you've come up with triangles was 180, okay? All right, triangle inequality conjecture. All right, so we're going to see if we can come up with this conjecture. All right, so it has something to do with the lengths of A, B, and C. So let's say A, B, and C. All right, so let's see if I can get this to work. This is kind of new for me. Okay, let's give this a try. All right, so here we're doing the conjecture. All right, so, no, it's this one. Yep, this one. Okay, so we have these three sides of a triangle. All right, and we want to see if we can come up and make a triangle with these. So we could move that over here, and good enough, we have a triangle. All right, so we could move these things all over, and we can see different situations where we could have a triangle, but we want to see where we can't have a triangle. Gosh, this is not working very well. There we go. All right, so here we can have a triangle. We could make this really short. Could we have a triangle? You bet we can. We could put it here. So it's basically whenever those circles that we have cross. All right, so let's see if we can find a place where we couldn't make a triangle. So maybe if we made these really short, like maybe perhaps something like this. Like here, we wouldn't be able to make a triangle because their two sides aren't long enough to be able to reach. Okay, or perhaps if this line was very long, then there's no way that the end of C would be able to touch D. All right, and so we're going to come up with some sort of conjecture or what we think is going on here. All right, here they're about the same, but this doesn't make a triangle, right? So if they're exactly, like let's try this. Let's say if we did this was 10, and then we did each of these be 5. Could we make a triangle? All right. So there we wouldn't be able to make a triangle either. So what's the relationship between the two shorter arms and the longest arm? All right, think about that for a minute. In class, I'll have you guys try and come up with this by yourself. But let's go back to our notes, okay? So, I don't know how to describe this, okay? So if you can come up with something that makes sense, that would be great. So I'll just go ahead and write the conjecture. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay? So for example, if I were to write this in like an equation, we would need to guarantee that A plus B is greater than C, or A plus C is greater than B, and B plus C is greater than A. All right, so let's go back and look at this. All right, as long as when we add, like for example, if we made that 9, we add the two smallest, 5 plus 5 gives us 10, which is greater than our other side, okay? And when we write down these two, this conjecture that we have here, you could always, this will always guarantee if you add the two smallest sides should be greater than the largest. Okay, so for example, this one, for 3a, these are our two smallest. We add those together. That gives us 14. And is 14 greater than the largest side of the triangle? You bet it is. So yes, this makes a triangle. All right, let's try this next one. The two smallest, there's 12 and 8. That gives us 20. And is 20...
We need all those students going to the Genius Party to come to the Commons at this time.
All right, so that's the two smallest angles. We add those together, that gives us 20. Is 20 greater than 22? No, it's not. Okay, so we'd say no. All right, let's try the next one. We have the two smallest. We add those together. That gives us 16. Is 16 greater than 17? No, it does not. So we wouldn't be able to make a triangle with those three sides. Okay, let's try this next one. These are our two smallest. All right, that gives us 18. Is 18 greater than 19? No. Okay, look at these two smallest. That gives us 12. Is 12 greater than 12? No. Okay, so these are a lot of non-examples. Okay, and then our two smallest here, that gives us 10. Is 10 greater than 9? You bet it is. Okay, so let's try one more time with this. If we have two smallest angles, let's try 3 and 3. Okay, we just need to make, if you add those together, 3 and 3, that gives you 6. We have to guarantee that the longest side, AB, has to be less than 6. So add the other two together. So here we could make a triangle. Here we could make a triangle. All right, but at 6, we can't make a triangle. All right, like here you wouldn't be able to see it at all. Okay. All right, so let's try it again. If we do like 6 and 3 or 4. Okay, let's do that. Add those together. That gives us 10. So we can make a triangle for any of these situations as long as the longest side is less than 10. All right, so 9 is the closest or the smallest that we could make. All right, assuming that we're using integers, okay, or whole numbers. All right, we don't have any negative lengths. All right, but if we did 10, we wouldn't be able to make a triangle. Right, and definitely if we had bigger than 10, there's no way that these could ever be able to touch. Okay, so there we go. That is the triangle inequality conjecture. Okay, so just this is what I would focus on. The two smallest sides, add those together. That should always be greater than the largest side. All right, now let's look at the side angle inequality conjecture. Okay, so it says here the shortest side of a triangle is always opposite the something, and the largest side of the triangle is always opposite the something else. Okay, so let's go and look at this other one and see if we can come up with this conjecture. Okay, so the largest angle, so I can move these things all over. Okay, the largest angle, okay, let's look at that. It says 95. The other ones are like 60. Let's actually make it so it's very apparent. Okay, so we have the smaller angles, which are 25 and 14. The largest is 141. Okay, what can we tell about the relationship between the angle and the opposite side? Okay, so here we have, here, maybe look at it like that, okay? So we have two of the sides that are 8, and then the other side is 16, okay? And how does that respond to the angles, all right? So we may realize here that the largest angle has the largest side, and the smallest angle has the smallest sides, okay? And we can mix this all around, okay? So here we have our smallest is B, which is 16. Sorry, I wish I could write on this. The smallest angle is B, which is 16, and the side is 5. The medium angle is 48, and the medium sized of the angle is 13. And the smallest angle, 117, across that, the opposite side gives us the largest side, all right? So from here we can say that for any case, the shortest side of the triangle is always opposite the smallest angle, or vice versa, okay? So if we have the smallest angle, well, also the opposite side is going to be our shortest side. And the largest side of a triangle is always going to be the opposite the largest angle, okay? And again, vice versa, the largest angle, the opposite side will give you the largest side. Okay, so let's look at 8 or 4. A. All right. So here you'd maybe want to, it says order the sides of each triangle from the shortest to the largest. Okay, so let's start with our shortest angle. Our shortest angle is right here, 54. So our shortest side is going to be UT. So we would write UT or TU, doesn't matter, okay? Now we'd want to find the next smallest angle, which would be this angle, which is 60. The second largest side is going to be ST, all right? And then the largest angle, which is 67, will give us the largest side. So that gives us SU. All right? And if we had these numbers that give us the sides, we could obviously see that we see that correspondent. Okay? All right, so we have some more examples on here. I'll maybe do a couple of those. I feel like you can probably come up with that pretty quick. All right, so smallest angle. Well, we have two smallest angles. They're the same. So we could just say KM, so this would be KM, is congruent to KL. Okay, and then the largest side, then after that would be the 80. That would give us the largest, which would be ML. Okay, so we have two sides that are going to be congruent just because they have the same angles. Okay, it's kind of like an isosceles triangle. Okay, all right, next one. Here, smallest is 50, so we're going to look at the line across, or the side across that angle. We'll do KL would be our smallest angle or side. Our next would be the 55, which gives us LM. And again, the order of those letters don't matter. And then the last one would be 75, which gives the largest side, which is KM. Okay, and again, we have two angles that are the same, and we have the smallest one here. So the smallest side would be GF, and then EF is congruent to EG. Okay, they have the same sides. Okay. All right, and then we're doing basically the opposite. They give us the sides, and we need to find the smallest to the largest angles. So order the angles of the triangle from the smallest to the largest. Okay, so here's our largest side. That means this must be our first angle, or our sorry, I'm supposed to do I'm totally backwards. Okay, smallest. Okay, so our smallest side is 14. That means that this is our smallest angle. All right, so we can just say angle D. The next would be this one, would be angle E. And then the smallest side will give us this, the largest side gives us the largest angle, gives us angle F. All right. Again, smallest to largest, smallest side, angle A is our smallest angle. Then we count 22, which gives us angle B. And then 23 is our largest side, gives us the angle C. All right. Okay, so, and you can do the same with C. Okay, and then we have just a couple more things we need to cover before we're done, is isosceles triangles and equilateral triangles. So, as the picture kind of suggests, okay, isosceles triangle has two or more equal sides and two equal angles. Okay, so those are, when I say equal, those are congruent. Okay, so in this here we have two opposite angles and two congruent angles and two congruent sides. Okay, equilateral triangles, just like the isosceles, we have two congruent angles, but this time we actually have three. So we have three congruent sides and three congruent angles. Okay, so these would be the same angles. All right, so here's a question for you. Is an isosceles triangle, or is an equilateral triangle also an isosceles triangle? And you bet it is, okay? So, because an isosceles triangle has to have two congruent sides, and an equilateral triangle also has two sides. It actually has three sides. So an equilateral triangle, or the isosceles triangle is, an equilateral triangle is also an isosceles triangle. Sorry, I probably just totally confused too many people about that, okay? But you don't really need to worry about that. All right, so, and when you have a equilateral triangle, we know a triangle is 180, and if all of the angles are congruent, we know that each angle is going to be 60 degrees, okay, always. All right, okay, say that one more time. So an equilateral triangle is also an isosceles, but it's not vice versa, okay? An isosceles triangle is not an equilateral triangle. All right, so let's do some of these problems really quick. All right, we have three sides that are congruent, which means we have what type of triangle? Equilateral. Okay, so we know that all the angles are the same, so x here is 60 degrees as well. All right, here B, we have what kind of angle that is that? Since we have two sides that are congruent, we know it's an isosceles triangle. Okay, so if it's an isosceles triangle, we know that this angle and this angle are the same. Okay, so we could say that both of these could be x, and we know that a triangle is 180, so we could add 30 plus x, and then all we need to do is solve for x. So we could subtract 30, subtract 30, that gives you 150, equals 2x, and then divide both sides by 2, and you end up getting x is 75 degrees. All right. Okay, what type of triangle is this? It's also an isosceles triangle. Okay, and make sure that whenever you have two congruent sides, okay, the two angles that are also congruent are at like the bases of that triangle. Okay, so we know that this is also 46 degrees. The congruent angles will never be between those two congruent sides. Okay, so same thing, we know a triangle is 180, so we'll add 46 plus 46 plus x, and then we will solve, and you'll end up getting, well, 180 minus 46 minus 46 gives us x, which is 88 degrees. Okay, just a few more. What type of triangle is this? Okay, it's also an isosceles. All right, so these would be the two sides that have to be congruent. So x must be 11. All right, again, this type of equation, or triangle, what type of triangle is this? Since we have three sides that are congruent, we know it's an equilateral triangle. So like equal sides, equal angles, okay? So they want us to find this measure, okay? Measure 2. All right, so I'm not exactly sure why they give you x plus 69. I don't know if they're asking for what x is, but either way, we know that this is 60 degrees. We know that this is 60 degrees. Let's just go ahead and see if we can solve for x. Okay, so we know that the measure of 2 is 60, and then that's equal to x plus 69. All right, so if you subtract 69 from both sides, you'll get x equals negative 9. So I'm not sure if that's what they're asking for, but you could for sure do that. Okay, and then the very last one here, it's also an equilateral triangle. All three angles are congruent. All right, so we know that the sides are also congruent. So here, if we want to find what x is, we would know that 9 is equal to 2x minus 7. We'll add 7 to both sides. We'll get 16 equals 2x, and we'll end up finding that x is equal to 8. Okay, yeah, my guess is they're probably wanting us to solve for x, but that doesn't really, I didn't say that on the notes. All right, so I think that is everything. Next we're going to be doing 10.2 is similarities. Fun. If you have any questions, let me know. We have homework right here, 10.1, basic triangle properties. So you should be able to do all of this with your notes, and there's 3 pages. Don't forget, there's 3 pages. I then try to do my best to write at the very bottom how many pages there are for the homework. Okay, so 1 out of 3. And thanks for watching. Share this with your friends, and subscribe and like. Okay, all right, thanks.